Okay, hi everyone. So we're here with a question bouncing downstairs, and basically we're told that this marble bounces down in a repeatable or rather regular manner, and what that means is simply that this arc, right, this parabola is basically a translation of this parabola, and so on, right? And we're told the height, right, of the stairs as well as the length of the stairs, right? Both of them are L, so it's a square kind of staircase, and we're given the coefficient of restitution, right? So in the question, they say the coefficient of restitution is Vf over Vi. So that means that suppose the object is falling down here and it will have some initial velocity, right? Vi is the velocity before it hits the ground, right before it hits the ground. So there'll be Vi. And then after it hits the ground, it's going to lose some of its kinetic energy in the form of heat and sound. So the Vf we expect is going to be less than Vi. So if Vf is in general E times Vi, and E if it's between 0 and 1, then that means that Vf is going to be less than Vi. So, or rather, the magnitude of Vf is going to be less than the magnitude of Vi, right? Remember the velocity of vectors. So, yeah. So with that, how do we do this question? So the question asks us for the necessary horizontal velocity, and basically the horizontal velocity and the bounce height, right? So let's focus on the first part over here. Let's focus on the horizontal velocity. So first of all, we notice that we know the distance, right, the horizontal displacement between the bounces are length L, right? Horizontal displacement between the bounces are length L. So if we know the time, if we know the duration of the flight, right? If they know the duration for each of the parabolas, the duration t, then we can find the horizontal velocity, right? So we have now reduced the question of finding the horizontal velocity, right? Because the horizontal velocity doesn't change with respect to over time, right? So the if we know the duration, right, then we know the horizontal velocity. So how do we find the duration? Okay, so suppose what do we need to find the duration, right? We know the duration is the time that the ball spends in the air, right? So maybe we can do something like half ut plus half gt squared, something like that, or ut minus half gt squared, something like that. But it turns out based on all the kinematics equations, the one that's most convenient is actually going to be the velocities, right? So we know that the velocity here is Vf, right, upwards, right after it bounces off. Then right before it hits the uh, stairs is actually going to be Vi like this, right? Incident, right before it hits the stairs again. So we know that the acceleration downwards is g. So it's natural that over time your upwards velocity is going to become a downwards velocity, right? And specifically, we know v equals u plus at, right? So if we know Vf, we know that Vf, the initial uh, velocity projected from here. Okay, it's a bit funny to call this initial velocity because Vf is sounds like V final, but it's actually the final after the bouncing, right? So this is our U, right? And then right before it hits the ground, that is our V, right? This is actually our V, and the A in this case is just G downwards. And so if we know this quantity, if we know the Vf, if we know Vi also, right? Then we know G also, then we know time, right? So once again, we've changed we've chased the quantities from wanting to know the horizontal velocity to wanting to know the duration, wanting to know the duration into wanting to know the initial and final velocities. Okay, so currently we have one equation relating the two, and the one equation relating the two is the coefficient of restitution, right? We have this. So one equation, we have two unknowns, one equation, so we need one more equation, right? Because in general, we need two inequivalent equations to solve for two unknowns. So how do we find the other one, right? So the other one we can use conservation of energy, namely that half mv f squared, right, plus mgl, right? The height of the stairs is L, so the vertical displacement as it falls down, it loses some GPE, right? So that GPE is converted to kinetic energy, right? So we have this mvi squared, right? You can use conservation of energy, or alternatively, right, this will give you Vf squared plus 2gl equals to Vi squared. Okay, so this is also another way, right? This is using V squared equals to U squared plus 2as, the kinematics equation, right? Actually, both of them, actually, on a side note, right? Actually, velocity V squared equals U squared plus 2as this as a connection with work energy theorem, right? Work energy theorem. So I made a video in detail about that, right? Link is in the description. There's actually a hidden mathematical, or not hidden, it's just there's a mathematical connection between the two that's not really emphasized a lot. Okay, so anyway, we have the two equations we want, two equations, two unknowns, we are very happy. And so all that remains to do is to try to write these two in terms of to solve these two equations simultaneously. Okay, so we substitute VF in we substitute df into the following equation. We get E squared VI squared plus 2GL equals to VI squared. Okay, so remember we want to find VI in terms of the constants, so VI squared equals to 2GL over 1 minus E squared. Okay, so that gives us VI squared. And what do we want to know? Right, specifically, we want to know, okay, we want to know VI. We want to know the exact VI because we need to know the exact VI in the VF. Right, so this is just going to be square root of 2GL over 1 minus E squared. And what's the other one? Right, VF is just E times that, right? E times VI. So that would just be this. Okay, so based on that, what do we need to know now? So now we know VF and VI in terms of constants that we know, right? Remember, we're provided with E, we provided with G, we're provided with L. So we need to find the horizontal velocity. Okay, so what we use these two facts, right? So we know that the VI down here, right, downwards, VI downwards, 2GL over 1 minus E squared is equals to, so that's VI. Actually, there's a way we can, so V equals U plus AT, right? There's a more systematic, we can just let one of them be. So what I mean is where VI is equals to E times VI plus GT, right? So okay, we need to be careful with the signs here, right? VI in this case, the final velocity is downward, right? Let's take downwards as positive, right? Let's take downwards as positive. So VI is downwards, then this one should be minus EVI, right? Because VF is upward, then over here it will be G times time. Okay, so time is equals to 1 plus E over G, 1 plus E over G times VI. Okay, and this will be equals to 1 plus E over G times VI, which is this thing, 2GL over 1 minus E squared. Okay, and so that's time. And what is horizontal velocity? Horizontal velocity is then just L. So Vx is then just length over time. And that would just be equals to, that will just be the inverse of this thing times L. So L G over 1 plus E square root of 1 minus E squared over 2GL. And simplifying, right? Simplifying, we just have 1 minus E squared can be factorized out. So that will give us square root of 1 minus E over 1 plus E, right? G in this case, we have this, we have G in the numerator, and L in the numerator also. Okay, so checking units, right? Checking units. Remember, checking units is always a useful way to check your answer, right? G has units of meter per second squared. Length has units of meters, right? And then E is dimensionless. So square root of this thing would correctly give you meters per second. So the units are in fact correct. Okay, so that's how we do this question. And all that's left to do is sorry, I forgot a factor of 2 over here. Yeah, this factor of 2. Yeah. And that is the correct answer. Okay, so all that's left to do, so now we've answered the first part of the question. All that's left to do is going to be finding the bounce height. So how do you find the bounce height? We know that at the peak, right, at the very peak, we can just use Suvat, right? Because we know VF Okay, we know VF is equals to, what is VF? VF, I'm gonna bring back here. VF is equals to this thing. So VF is equals to this thing. VF is this thing. And when does VF is basically the initial velocity, right? VF is basically this our u, right? And then when does we know gravitational acceleration is downwards, right? So when does the velocity become zero? When does v equals to zero? It's just VF divided by g. In terms of time, when does it become zero? It's just VF divided by g. But another way we should be to use v squared equals to u squared plus 2as. Okay, so we can either find the time and then we calculate it out, or we can use this and it will get us the answer in one step. Okay, so VF, right? So initially u is the amount upwards, right? So we're taking downwards as positive, so be careful with the signs. So 2 times a, so 2 times g times s. S is going to be a negative value, right? S is going to be a negative value. S is in fact S is going to be negative, right? So 2gs and this is equals to u squared, so this is e squared over 1 minus e squared 2gl. Okay, and this equals to 0. So we have this, and then simplifying down, we have s equal to s is equals to the 2g cancels out, minus e squared over 1 minus e squared times l. So we get that the height that it goes up to, right, the bounce height, right? Because taking downwards is positive means that this negative sign over here means that it's going upwards. So the bounce height is just e squared over 1 minus e squared times l, and that is in fact the correct answer. So we have solved the question, and I think the key, there's not a lot of, I wouldn't say there's a lot of insights from this question, except the fact that maybe the insight we can draw from this question is that if we choose our kinematics equations cleverly, right, we can save some working, right? So do take note of what quantities you know, what quantities you need to know, and then decide your kinematics equation based on that. So ideally you can do it in one step, right? If it helps, you can always break it down into multiple steps, but that would be a bit more costly in terms of time. Okay, so know the quantities you need to find out, right? And know what quantities you know, and chase these quantities around. So yeah, I'll see you in the next video.